Started. Start. Okay. Well, students, in the last class, we had derived an expression of an electric field of a dipole on its axial line. If we just have a look on the past derivation, which we did, we had considered a dipole placed at a distance from the origin r on its axial line. If we remember that, we call the distance from the origin of the dipole on its axial line in general r, and the distance of the dipole on either side from the origin as a. Then we had derived, if we remember it, then it was k 2p r by r square minus a square whole square, right? Actually, you don't need to remember this expression as such. Now, in general, okay, whenever we talk of a dipole, basically it is not of the large distance. It range, if it is on the atomic level, then it range to the order of 10 to the power minus 10, right? In a bigger molecule, 10 to the power minus 12. So whenever we talk meter, so whenever we talk of a dipole, so the order in general, you will not see big value. Okay, so if we consider a special case, actually this is the general case. Like if the distance r is quite far compared to the length of one of the charge from the origin. Now, like say, if r is of the order of 10 to the power minus 2 meter, that is 1 centimeter, if it is of the order of 1 centimeter, and if a is of the order of, say, I'm just taking 10 to the power minus 10 meter. Okay, then compare to r, a is extremely small. Okay, so all these are the comparison. R is 10 to power minus 14 times bigger than that of a, right? So this is the most general case. Like if r is 1 meter and a is of the order of let's say millimeter, 10 to the power minus 3 meter, let's say. Okay, then compare to a, r is much larger. So if r is large enough compared to a, then a square will be further small. Okay, then what this expression will finally turn, k2p, I'm writing in terms of vector, then this will be, we can ignore because the square of the small quantity will be further small, so we can neglect it. Like 10 to power minus cube, if I square it, this will be what, 10 to power minus 6, further small quantity, so we can neglect it, right? So if this is the case, then what we can do, we can neglect a square terms, right? If we neglect a square terms, then it will be what, r square, right? Then this will be r to power 4, and this r to power 4 with 1 r, it will cancel out. So what it will be, this will be 2p by r cube. I think we understand it. Then electric field, this k is for vacuum or for air, it is 1 by 4 pi epsilon. So this I can write it k, the same thing, I'm writing it again. This is double of, electric field is double of the dipole divided by r cube, k. Okay, this is 4 pi epsilon 2p by r cube. I want the students to remember this expression. You have to remember this expression, this one, because K we don't write it often. So please do remember this one. Okay. So how much is what is the expression of electric field on the axial line? This is K twice the dipole moment divided by the cube of the r. That means as the distance increase, the electric field will reduce by the cube value of the distance. Okay.